Hello everyone, welcome to my YouTube channel. Today I am going to explain gravimetric analysis of nickel plus 2 in ores and alloys. Overview of gravimetric analysis. Gravimetric analysis is one of the most accurate analytical methods available. It is concerned with the determination of a substance by the process of weighing. The element or radical to be determined is converted into a stable compound of definite composition, and the mass of the compound is determined accurately. From this, the mass of element or radical is calculated. The gravimetric analysis involves precipitation, filtration, washing of the precipitate, drying, ignition, and weighing of the precipitate. After introduction part, we will discuss ores and alloys. Ore is natural rock or sediment that contains one or more valuable minerals. Ore is extracted from the earth through mining and treated or refined, often via smelting, to extract the valuable metals or minerals. Whereas an alloy is a mixture of two or more elements where at least one element is a metal. Occurrence of nickel. Nickel is an element atomic number 28 between cobalt and copper. Nickel has been known for a long time as an element or as a mixture with other metals, but it was only isolated as an element in 1751 by Axel Friedrich Cronstedt in Sweden. Nickel occurs widely throughout the Earth's crust and is thought to make up about 10% of its core. Normally, nickel is found in conjunction with iron in laterite minerals such as nickel ferrous limonite or magmatic sulfides, such as pentlandite. Those the huge reserves found near Sudbury, Ontario in Canada. Example of some nickel ores are given below. Nickel alloys. Nickel alloys are used extensively because of their corrosion resistance, high temperature strength, and their special magnetic and thermal expansion properties. Analysis Introduction. The separation of nickel from other ions in a sample is a good example of specificity. In quantitative analysis, the amount of nickel can be determined by precipitation with dimethyl glyoxime from a slightly ammoniacal solution. Nickel 2 forms a precipitate with the organic compound dimethyl glyoxime. The formation of the red chelate occurs quantitatively in a solution in which the pH is buffered in the range of 5 to 9. The chelation reaction that occurs is illustrated below. Although the loss of one proton occurs from one oxime group on each of the two molecules of dimethyl glyoxime, the chelation reaction occurs due to donation of the electron pairs on the four nitrogen atoms, not by electron on the oxygen atoms. The reaction is performed in a solution buffered by either an ammonia or citrate buffer to prevent the pH of the solution from falling below 5. If the pH does become too long, the equilibrium of the above reaction favors the formation of the nickel 2 ion, causing the dissolution of dimethyl glyoxime back into the mother liquor. Chemicals and reagents. 1% dimethyl glyoxime, hydrochloric acid, ammonium hydroxide, acidic silver nitrate, unknown nickel ore sample. Procedure. 0.5 gram of unknown nickel ore sample was accurately weighed and completely transferred to a 100 ml volumetric flask, acidified with 1 to 2 ml of HCl solution and made up the volume of the flask with distilled water. Now 50 ml of nickel solution was transferred to a beaker and then 2 ml of 1% DMG solution was added in it. The solution was heated at 80 degrees centigrade and allowed it to cool. After cooling, ammonium hydroxide was added in it. Ammonium hydroxide was added continuously until red colored precipitate was obtained. The precipitates were filtered through G4-sintered glass crucible and then washed with cold water. Washed continuously until the precipitate were free from chloride, used acidic silver nitrate. The G4-sintered glass crucible along with wet PPT of dimethyl glyoxime was kept in oven in 110 degrees centigrade. After dried and cooled at room temperature in desiccated weighed the G4-sintered glass crucible along with precipitates of nickel dimethyl glyoxime. Now moving towards the observation part. Weight of sample is 0.5423 gram per 100 ml. Weight of empty G4-sintered glass crucible is 50.6042 gram. Weight of precipitate of nickel dimethyl glyoxime is 0.0853 gram. Weight of empty G4-sintered glass crucible plus weight of precipitate of nickel dimethyl glyoxime is 50.6895 gram. Molar mass of nickel dimethyl glyoxime is 288.91 gram per mole. Molar mass of nickel is 58.69 gram per mole. Here is the calculation of our analysis.